If you want to learn how to gain insights you can act on and solve business problems with data, all while building a data-driven culture at your organization, sign up for Pragmatic Institute's new course, Data Science for Business Leaders. Find out more at pragmaticinstitute.com/data. Welcome to Data Chats, a podcast by Pragmatic Institute and the Data Incubator, where we tackle data topics and trends with experts, industry leaders, instructors, and alumni. I'm your host, Chris Richardson, and today I'm sitting down with Gábor Békés, author of Data Analysis. He's an assistant professor at the Department of Economics and Business of the Central European University in Austria and a senior research fellow at the KRTK Institute of Economics in Hungary. Gábor, thank you so much for joining me today.
It's my pleasure.
I look forward to talking to you about a lot of the things that you've been up to, including data analysis for business, economics, and policy, your co-authored text that I've gotten halfway through, I have to admit. It's a big book, and I got it last week, so I haven't had time to finish it, but I do have to say that I'm really impressed how you can put everything together in a way that's accessible for fairly new people, but also reveals a lot of the depth that, you know, more seasoned data analysts might want to get from a book like this. So let's jump right into it. Maybe you can tell us a bit about your background first before we get into the text itself.
Well, first, thanks a lot for the compliment. I mean, it's 844 pages, right? So it's not expected to be read overnight. So that's completely okay. I mean, my background, so I'm an applied economist. I normally do research in a variety of fields about firm behavior and performance and teams and organizations. Applied economist means that I work with data, with large data sets or small data sets, with surveys and big data as well. And, I do analysis. That's what applied economists do on these fields. And one thing that is not necessarily standard is that I had a few years between, working in academia and my studies, and I worked for an investment bank in London. So I have a little bit of background in business, and I've done ever since a couple of consulting projects. Mm-hmm. So this is how this idea that you want to work on topics and questions that are interesting beyond academia kind of came about. And I've been teaching a variety of versions of data analysis for 10 years, originally with my co-author, who's also Gábor, and then alone. So this has been, that's the past.
Yeah, I mean, obviously you bring a wealth of experience. And one of the things I wanted to start asking you about was the idea of a textbook, especially one as large and as full of complex ideas as this one. Obviously, that takes quite a while to put together, to write, to edit. I've seen never as big as this, but I've been through the process, and I know how sometimes very slowly it can be. And then data science we think of as, cutting edge. Every 5 seconds you have to learn something new. I wonder how you took data analysis principles and chose them and fought with that possibility that, technology is changing, ideas are changing, but there are certain things that will last quite a while. I mean, some of the comments in the book are clearly designed, not to be thrown away after the newest thing comes out or the newest app comes out. So I wonder how you make those choices, and maybe you could point to some of those things that are kind of like tried and true, and maybe you had to make other decisions about what to keep and not.
I mean, I think it's a great angle, and so people who are coming from the data science world and engineers, they would often point to the plethora of applications and new tools and new methods, while people who are kind of have this classical training or academia, they would say, well, we know things for a long time, right? There is nothing new here. Right? Most of the things that we know, we have known for a long while. Right. So there is, there is these two worlds, and I think there is truth in both. And what we try to do is curate content, right? In the sense that there is a lot of things that we know. And so the question was like, what are the top 50, 20, whatever things that everybody who is working with data should know? right? So this curation process was the hardest, and not only to decide what to put in, but what to not include, right? Both questions were pretty hard, and I think the experience was important because of this, to think about, okay, what are the things, old or new, that we should talk about. And in terms of experience, I mean, not only academia, but like, in business and consulting, but also, we, both of us, did a lot of public policy projects. We worked for central banks and governments and international organizations. So what are the things that people need? Now, in terms of examples, I think the idea of a regression, which is basically conditional comparison in essence, that you are comparing average values of some variable by other variables. This idea of conditional comparison, I think this has been around for a long time, right? People know about this, but it's still very important, and it's still an essential building block. And it's a way to think about what is data analysis. Data analysis, in essence, is really about comparison, right? Conditional comparison. With easier tools, looking at group averages, to super complicated tools, using machine learning libraries to make a prediction for different features with different features. But in essence, there is comparison. So this is something that we wanted to communicate throughout the book, that this is important. So that's kind of the evergreens. And in terms of the new thing, so traditionally in most university courses of data analysis or econometrics or quantitative methods, prediction and machine learning is not part of the core curriculum. Not only machine learning, right? That's sort of the newer bits, but even the idea of prediction, of how we should think about making predictions, that's typically not part of the core curriculum. And we wanted to make it as important, and thinking about causality, which is part of the core curriculum, because in the real world, you often want to make predictions. And this is why you get paid. And this is not only true in business, it's also true in public policy. You have a new tax policy or an investment, or a new measure, and you're interested to predict its impact on people, right? So not only in business, but also in public policy. So, what I think as, I wouldn't say new, but something that is not part of core text is prediction. And so we wanted to keep, something that's been around for a longer time, but also add some new twists.
Yeah. Were there any difficult decisions where, I guess, you had to choose what you could focus on? Maybe there was something you were using, and then you thought, well, first of all, yeah, what were you using, or what do you typically use? What are some of the key features of your stack, and how did that translate into the sort of principles that you were thinking about?
Well,
not that you have to name everything, but I'm curious if there's a few things that you tend to use, and then how did you choose
in terms
what
of
to
using,
include?
you mean software or tools, or what do you have in mind?
Yeah, exactly. Are
No,
you a
okay.
Tableau guy, or what do you tend to use?
Okay, cool. So funny you should say that. We wanted to make this book, and that also goes back to your earlier question. We wanted to make this book tool agnostic. We are not married to R or Python or Stata or SPSS or Tableau or Excel. We wanted to make everything to be independent of tools, and the reason for that is that tools are changing. So when we were both old enough that we started to use different software that we use now, and so we have gone through this idea that you change your tools and you have to learn new stuff. So we wanted to have a book that has no code in it, as you might have seen, as opposed to some other books. There are no code in it, so that people with any persuasion might like and use. We wanted to have some principles, right? So that's about tools, but in terms of principles, I think we wanted to push some principles, and one would be that you have to make, and that the analyst has to make a lot of choices, and that should be explicit, and you should think about those choices, and not stick with the defaults, from using color schemes to making decisions about engineering, data engineering, and filtering, and designing your sample. So you have to make these, to push that the decisions, that there's a lot of decisions, and it's fine to make them. You have to make them. There are no rules. It's not statistics. It's not science.
Mm-hmm.
There's a lot of decisions that you want to make, and you have to be upfront and explicit. So this was certainly one kind of principle that we wanted to push. And the other would be probably to be transparent and, write code when you can, and write code for the purpose of transparency and reproducibility. Mm-hmm. Document what you do and stuff like that. So this is pretty academic, but I think it's also pretty standard in business. And this is not something that you teach students early on, but we wanted to kind of make that clear pretty early on in the book.
Yeah. Well, one of the reasons I ask is that often if I'm coming up with a lesson or I'm working on something, it's very hard for me not to think about, well, this is how you would write it in Python, or this is how you would do that. And so it sounds like it wasn't a challenge necessarily for you, or maybe it was, to get away from the actual applications that you might be using or the languages you might be using, and to abstract it. How was that process?
So first, I think it's important to be able to think in meta code, or in pseudo code, in the sense that to think, so first I'm going to do this, then I'm going to do that, and then I'm going to run this regression or this model. This is going to produce estimates, and I'm going to do a graph to show this and that, right? So it's important to be able to think in terms of process. The second is that the fact that it's not in the book does not mean that was not an issue. Quite the opposite is true. So there are 47 case studies in the book, and each of them has, one or two or three bits of code, and everything is available in R, in Python, and in Stata. So the three most frequent languages. So while I didn't have to think about this writing the book, I had to think about this all the time, because we were writing code in different languages and translating them with a lot of people's help, translating them into other code, and then figuring out, so why the heck, can I say heck? Why the heck are
whatever you like?
Why the heck is a histogram not the same in Python, R, and Stata? Why is this the case? And then you have to drill down into the details of coding and think about, oh my God, the bins are differently defined as defaults in different languages, and this is why histograms look differently across different platforms. So on the one hand, when we were writing text of how to do stuff and what is a logistic regression and when does it make sense to use it, we were not thinking about code. But as we were writing case studies, which again make up like 1/3 of the property in the book, it's 1/3 about pages. So we constantly thought about code and translating code, one code into another, and it was an absolute nightmare.
Yeah. Okay. No, that I figured, because that tends to be what happens in the background. I mean, it looks so perfectly concise in the book that, yeah, I knew that. I had a sense that you had done some editing, or there must have been some headaches. But that's interesting to think about. I wonder if you learned anything from that experience that you think helped make the book maybe more understandable, or translated one code. Like if you only use Python, this book might have been quite different, I wonder.
That's a very interesting question. I never really thought about this, but one thing is that to think that oftentimes you need to understand more about the algorithms that run in the background. What is the exact process in when you do classification and you run random forest? What is exactly that is done, and what are the options? What are the parameters? In R, you have more choices. In Python, the default is good, but the default in R is not good. So we had to think about, okay, so which one is good? And understand a lot about the algorithms behind it. And then it's going to be one sentence in the book. But then it was, 3 people working on looking through, the documentation of these algorithms and trying to understand the details. Now, whether there is any takeaway from this, apart from don't do it at home, I don't know. But probably that there's a lot of results. So this is the takeaway for you, that there's a lot of results in our work that depends on some tuning parameters, some settings in algorithms that we use, that we never think about. Right? That there is no like a single good solution that gives you, sometimes there's a closed form solution, right? So if there's a closed form solution, that's fine. But very often there's some kind of maximization going on in the background, and how exactly it's done, how the grid search works, how these stuff are done, are actually coded, that tends to matter. Sometimes it matters a teeny tiny bit. Sometimes it actually has quite an impact on the results. And we never think about this. And this is how I got to think about this. And I don't want to think about it, but yet we had to.
Yeah. Well, and I'm sure it made it a stronger book from that experience, even though I thank you for your suffering, which made it easier and more informative for readers, I think. So, yeah, thank you. I want to ask you, you mentioned already the case studies, which, are plentiful in the book and really help to get across a lot of the points that may be more abstracted without the case studies. So I wanted to ask you, first of all, how and why you chose these case studies. Maybe you had a guiding principle or something, and then maybe you could get into a couple of examples that you think are helpful for understanding some of the concepts.
Yeah, I mean, so there are topics that we wanted to use because we like them and think are important. I'm going to tell you two examples. And then there were sort of data problems or analytical problems where we had to search through a lot of case studies. So some of the case studies we already had in mind. And then there were situations where we tried out 5. And right, so we tried out about 2.5 times as many case studies as ended up in the book. So, a lot of some of them were dropped immediately, fairly soon. Others we entertained, and others were developed and then decided that's not good. So how did we pick the ones that we did? So there were topics that we liked. So I like soccer, football. And so I wanted to have some examples about sports and football or soccer in particular. And then we also wanted to talk about public policy. So my colleague, he worked on health and retirement. So we wanted to talk about health in an international context, comparing smoking habits and health benefits. So health was another issue that we wanted to talk about. That's maybe not as traditional in econ or in business books, but health and sports, these were pet projects or pet interests. Mm-hmm. And then we also wanted to use the textbook to talk about important social issues. So, one thing that is, one example for that is that it is important to understand why women make less money than men do. And I think that there's a lot of discussion about this, but most of the discussion is about people who are already convinced about this fact and agree with each other. And that's not a huge challenge to talk to them. Now, we think that through data analysis and through thinking about the data, we can talk about important social issues. What happens when there's an earthquake in a poor country? Why do men make more than women? And so one case study is about understanding the gender gap in the US and why is there 15, 20% difference in earnings? What is the reason? What are the age component of this? What are the professional component of this? How should we think about this? Is it kind of a selection issue? Is it kind of a discrimination issue? And have this conversation, but have this conversation with data, while we focus on the analytical process and understanding the steps, we also have to discuss this. And I think that's kind of a hidden purpose. And then, for other case studies, we wanted to find large data sets that are useful for many. So we scraped, some of the case studies we collected the data for. So we scraped data on hotel prices because it's just a natural field where, most people know what is it to try to find a hotel, how to think about comparisons. And you can replicate the same story in different cities. So there was these practical issues that we wanted to talk about something in the book on one city and then have it as exercise for other cities that, people in groups can do, right? So that was another hidden agenda to have data sets and projects that give themselves to exercises on the field. So this is how most of them came about. Now, in terms of examples, so let me give you 4 examples, and then you can pick which I talk about more.
Sure.
What you think is more interesting for the audience. So when I mentioned football, so one case study is about what happens when a team changes its manager. Is it there's a team that's losing, and that's that goes beyond soccer, obviously. So there's a team that's losing, and it fires the manager, the coach, and then there's a new one. And is it going to make the team perform better in the short run? So that was one of the case studies. The other was a prediction exercise where we have data on swimming pool tickets, and you want to predict how many people will come in a given day.
Mm-hmm.
The third is another prediction exercise where you want to predict if a firm will default or not in the next 2 years based on some data that some features that you have about them. And the fourth is, so there is a merger between two major US airlines, and you're interested in figuring out what is the effect on consumers. Four examples. Which one do you want to hear more?
I just want to say though, for listeners, like as you're describing these, which is a nice, very just a sliver of all the case studies in the book, they seem quite disparate, and as if you were to get a job as a data analyst, I can't imagine that you would be maybe there are some cases, but in most cases you wouldn't be dealing with all of these things, all of these different scenarios. But by reading about them, I think it makes you a more versatile person to be able to analyze different situations, right? So even if you're never dealing with the soccer example, which is what I want to talk about, I think is very interesting, just seeing how that's done may help you in a totally different situation. And so that's one of the things I've sort of picked up myself, having read on data analysis, is that I'll read something, like I'm not a super big football or soccer fan. I definitely don't care myself whether a new manager will help or hurt a team. Like that's not something that's challenged me and that I want to predict personally. But hearing how this works is always going to be beneficial, even in very different situations. So I think, I just want to plug the book as something that helps you think. I guess linearly might be a way of considering it. I don't know if that's linear thinking itself.
So, okay, so first, thanks for the compliment. I appreciate it. The second is that, so before we talk about the case, that is the first sentence of the book is data analysis is a process.
Mm-hmm.
And we actually thought about the first sentence. It's not as good as some of the first sentences of Tolstoy or other novels, but it was carefully picked. The first sentence, data analysis is a process. So when you say kind of linear, not necessarily linear, but that this is a process and you should think about this as a package or as a process, I think that's very important. And eventually the case studies, all of them, try to pitch this process that starts with a research question, and then you think about what kind of data do you need or you have, whether you need to enrich it, whether you need to make some changes. Think about your sample, the analytical process, describing the data, maybe understanding some problems that you have, and then doing the analysis itself, then maybe going back to the data and thinking about maybe I need something or I forgot something. So have this back and forth between looking at your data and then doing the analysis. And once you're done, or you think you're done, you want to have some results. You want to interpret those results. So there's a lot of emphasis on interpretation, of understanding. So the result is 0.3. So what does that 0.3 mean? And I think this is super important in real life, because in real life, this is, a lot of what you want to do after you've done the analysis. You don't do it for an academic report, right? You want to make sure that that there is some takeaway, and then there's an interpretation of your results, and then you want to answer your research questions. So in that sense, this is, I hope, what you kind of picked up, that there is this process or lineup of events, if you will.
Mm-hmm.
And then
I was just going to say that because they are quite different, like the examples you just gave, while the process will remain the same, I've seen books, I've been reading where it's always, a financial report, and this is how the output goes. So it can become very sort of automated in your thinking. But as soon as you add all these different scenarios, then you really get to understand the process, as opposed to, like press this button, then press this button. So it's really powerful. I want to hear about the new hires and whether or not you should hire a new manager for a failing team.
Right. So no, I mean, just to finish off this train of thought, is that in some sense, all these case studies are metaphors, right? You
Mhm.
are using them to get, not just to answer the question, but to get a feeling. Okay, so this, it looks like, when you see something later on in your job, okay, it's not exactly this, but it looks like that example that I had, and
Exactly.
we heard back that oftentimes when you do interviews, actually in consultancies, you get very similar questions to ours. So football or soccer. Um, so the question is this: there is, there are teams in a league. In a typical league, you have like 20, and there are about 40 rounds in a year. So some teams will perform worse than expected, and then during the season they will fire the coach and they will have a new one, right? So there are changes that are planned and stuff like that, but often you change in during the season. So the question is, let's try to compare, going back to this idea of comparison as a key idea. Let's compare teams that they fired their coach, and let's compare the performance of these teams before and after, right? So you want to say, okay, if I see that the performance improves after the coach is fired, then we should do it, right? If we underperform, we should just get rid of the guy and have a new one. Fantastic. This is what we see, right? We see comfortably that team performance improves. If you compare 6 games before and after, you would see that the 6 games after the new guy, the team performance is substantially better. Okay.
Hmm.
So what's the other thing you often ask is, what can go wrong, right? What can go wrong? Is there a problem with this analysis? Well, there is a problem with this analysis. There are a few ones. The first is that if you go a little bit back in the data, you would see that the 6 games right before the firing is actually worse than kind of before. So there is a dip before the firing, right? So you can argue, well, there are problems. The teams are underperforming, but in addition to that, before the firing, players already know something, or there is a discussion. There was a problem. So there is actually, a sharp decline right before firing. So if you compare the performance of teams after the firing and not immediately before, but a little bit beyond that, you see there is still an improvement, but not much. That there is this kind of sudden gap and then reversal. And it turns out that this kind of pattern, and it's fantastic that you mentioned this idea of what our case studies used for. It turns out that you see this kind of dip in many other applications in economics. When there is an intervention, there's either a tax break or an investment, or you fire a manager, or many other applications. You see that there is a drop. It's called an Aschenfelter drop. Labor economists or people who have econ background may have heard it. Aschenfelter is a super famous economist, and we're a big fan, and we were hoping he would also get the Nobel Prize, but he didn't. But never mind. But my point is that what we see in soccer, right, this pattern that there is a decline and then there is a sudden drop, the action happens, and then there is this reversal. This is not specific at all to soccer. This is a very general pattern. And if once you see it, you're going to recognize it if you see it elsewhere. And you're going to remind, well, just because I see a large improvement after an intervention, it doesn't mean that it's actually a large improvement. It may be because before the intervention, there was something special. So this is how it kind of helps you to think about real life. Okay. So is this the end of the answer? It turns out it's not the end, because what you really want to do is you want to compare to other failing teams that don't fire their coaches, right? So you want to compare how does this pattern compare to other teams that are equally suck, but they don't fire their coach. And it turns out that for the data that we use, which is English Premier League for 20 years, in English Premier League for the period that we look at, these teams that don't fire their coach mid-season tend to improve just as much as those who do. There is a little bit of improvement, right? Bad periods are followed by good periods. There is some reversal of fortunes, whether you fire your coach or not. Now, importantly, this is a short term, right? So we look at the next 6 games. In the long run, years and years after, they may do better. So you're not saying that you should not do it, but clearly what we see is that in the short run, just because you see an improvement, it's not because of a change of coach. There you go.
There you go. That is interesting, and like you're saying, it helps illustrate a much bigger point, and it makes me think also like the records from the English Premier League would be great. That like that's been kept. I'm sure they're quite accurate and relatively available, or you could download it or something. Do you have advice for people who are working at organizations that may not have kept great records, in terms of keeping their own data, or maybe they're in a sector that the data isn't free flowing like it would be in sort of like a public facing like sports. We get to see how many goals are scored, baskets are shot or missed or whatever. And so like that seems like a great area to do data science. And we've seen in sports, a lot of interesting stats come up. I was watching baseball the other day, and just the level of detail, like this guy hits better against left-handed people 25% of the time. Like it's amazing how you can break that stuff down because that data is available. So I wonder if you have any tips for people where the data isn't as readily available, or maybe they have to, I don't know, there's a different way of thinking about data in some cases.
I think the idea that what kind of analysis is possible is driven by the size and quality of your data is really important, right? Is that depending on both, and I think both quality and size matters, right? So not only size matters, but also the quality. It's not just big data versus like smaller one, but also how reliable, sports data are extremely good quality. Right, there's very few problems. If you look at most other data sets, both within companies and in public domain, there are a lot of problems of quality, reliability. So I think the important insight is that you have to understand what are the limitations and opportunities that your data gives you. If you have 15 data points, there is only so much you can do. If you have 150, you can do much more. And if you have 1 million, then again, the opportunities are wider. For this particular exercise, we didn't need that much data, but we still needed 10, 20 years to have enough variation, right? We needed to. So in this case, what we needed to have is we needed to have enough firing during the season so that we can make this comparison meaningful. We needed teams that fire their coaches. The other thing, right, is that you need variation. If I wanted to compare teams that fire their coach mid-season with teams that don't and they equally suck, you need variation. If all the teams fire their coach when they suck, you cannot study this question. You cannot answer this question. So you need variation, right? That's also important. If you want to understand how a cut of your price will affect your consumers and the demand and your sales, you need to have had different prices for your product. If it was always priced $4.99, that data, doesn't matter how much, what the size of it. If it's always $4.99, you're never going to learn the variation of consumer demand by price because it's always $4.99. So, that's not a question you can ask. Right? So this is also a variation in your object. That's something that you want to also think about. Here we had that variation and we needed 20 years so that we would have enough variation.
Yeah, I wonder if in doing this work and in your experience, there are kind of telltale signs that a data project will or won't be successful. So as you've already said, if you don't have robust data, if you don't have a large amount of high quality data, then already, garbage in, garbage out. You can't necessarily do much.
It's not garbage in, garbage out. It's just that your methodological choices are much more limited. And maybe all you're going to do is group averages. That's it. Right? Yeah. You have to live with the fact that it's not going to be machine learning. It's going to be group average. My friend, if you have 25 observations, that's what you're going to do. And that's fine. Right? It's not just garbage in, garbage out. That's of course true. But beyond that, also that the size of your data are going to limit, the tools and the methods and the questions you can have.
That's a good point. So maybe to rephrase my question, have you seen in your experience places where there are going to be clear limits? So data, the input, obviously that's one place, but along that process, are there places where you've seen that, that's a telltale sign that you need to only do this, or if you try to do this, it's not going to work? Like, what would an experienced data analyst be able to see that an inexperienced one might not?
Wow, this is not an easy question. I mean, it's because it's so case specific. I mean, I'm struggling to find like a general theme in this case. I mean, apart from the fact that you have an organization that want to ask more than the data allows, or the size of their data allows, I think another telltale sign would be the lack of investigation into the quality of your data. I think that's something. So if you see that, so here it is. If you see that an organization has this approach that I have this data, I'm gonna put it into my computer, I'm gonna hire two analysts, and then they're gonna tell me the truth. That's a telltale sign that they don't know what they're doing, and there are minefields ahead.
Hmm.
Right? Many, because data is so prevalent, and people read all the good use cases. They had this idea that and then there are all these automating technologies and all these libraries you can access for different tasks, is that you have this idea that you just plug in the data, run something, or you got people to run them, and they're going to bring the result.
Mm-hmm.
So if you have and if you and the opposite is, if you see humility towards your data, that I understand there are problems, I'm willing to spend time, effort, money on understanding my data and cleaning and just figuring out problems, and be humble about that. Yes, it's going to happen. That's actually a good sign.
Hmm.
If you see a budget and like hours, and you see, well, a large amount of hours are put into figuring out the data and the quality and what variables mean. We started a book. If you've as thoroughly read the first half as you said you did, you might have come across this. We start talking about data quality, and what is the coverage of variables, how reliable they are, what is the validity, and these are quite meta when you read it. But when you go and work with data, it's really important that you think about what is the actual meaning of a variable. Is it doing what it says it does, right? So if you see an organization is open and paying attention to this, that's a good sign. If it doesn't, that's a bad sign.
Hmm. Yeah, it makes me think actually of situations where, like you, the data analyst, may be very well aware that there are some problems with the data that you want to dedicate that time, like you just mentioned, but that the stakeholder, maybe the manager, CEO, whoever it is that you're ultimately reporting to, thinks either explicitly or implicitly that you have data. Why am I not seeing the prediction of what this and this will do? Do you have advice, or have you seen ways of dealing with those kinds of situations where there may be a disconnect where, yeah, the people receiving the report expect some kind of perfect truth, even if the people creating the report, the data analyst, may know that it's not as simple as that, or that there may be flaws? How do you communicate those things to different kinds of audiences?
I wish I knew. I mean, it is. So I think this disconnect between managers or people at the level who wants to see the results, and the analysts or the data scientists, is, I think, the number one problem why so many projects fail,
Mm.
is because the expectations are just very different. And not always can you have like a magic wand and make people understand that we need more time, more effort. It takes more time. It's not going to happen in 3 months, because this, every use case is different. And I think, kind of going back to your earlier point about variation in our case studies, we wanted to show different case studies with small and large data and different problems, so that people would kind of have this genuine understanding that all projects are different, even if the process is fairly similar.
Mm-hmm.
The what can go wrong varies project by project. And you know experience comes with going through a lot of pain in different types of projects, and understanding that something will go wrong. You just need to figure out what, and how you communicate that when you are in a project already, I don't know. That's the I don't know. I've been there, done that. I don't know. I wish I did. It's a problem and a conflict. And if people are nice to each other, then it goes better than if people are not. I think genuinely it is important to teach data literacy or understanding a little bit about how data analysis projects go for a broader audience. I'm just finished teaching data literacy for lawyers, and I thought, well, lawyers, and yes, they are smart people. They will understand high level concepts, and you can talk about stuff and what's easy, what's difficult, how things are done. So I think this is that's the long run solution, to educate people who don't do data projects themselves, to give them some education so that they would be able to communicate with those who do.
Yeah, no, and as you mentioned, I guess it's like a minimum two tiers, where you want an organization to have some literacy, or you want people being hired to have some literacy about data. But you also, I think, in a project where you're bringing information, you want to make sure that people understand the limits of your data. I think is a sort of individual conversation on a project, but also a much bigger one in terms of social conventions about what our expectations are.
Yeah, and I think also trying to answer an earlier question is that, so how do you see, what are the good signs? So I think another good sign is when there is a very well defined research question. There is even a success metric, right? What I want to know, what is my loss function? I want to, so something, how will I decide if the project is successful? What are my metrics? What do I want to learn or know? When you have that, that means that there is a more more nuanced understanding, rather than I just want to make a good prediction.
Yeah.
Right. So I think that's also a good sign that good things can happen. Another is if there is so the other thing we try to push is the domain knowledge so we talked about managers, but let's talk about the analysts, right? So we often think as analysts that we have the data is going to tell us something, and I think it's deep-rootedly wrong. The data is not telling anything. There is this famous quote by Hayek, the Austrian economist, that without a theory, facts are silent. Without a theory, facts are silent. And I'm loving this quote more and more, because it tells you that you have to understand how things work. You have to have some theories. The data itself is silent until you try to test a hypothesis or understand a pattern. And often you need domain knowledge. So I think for the analysts, it is important to understand the business. It's important to understand how things work so that you can devise theories that helps you work with the data. So, we talked about management, and sure, there are problems, but also the hubris of analysts, that the data and the fancy methods will be enough. And it's not. If you want to talk about football, you need to understand how the process of coach firing happens. If you want to talk about wages, you need to understand, okay, how are wages set? What are the fields? What determine wages? What are the theory behind wage settings? So you need to have some kind of understanding of the topic.
Yeah. I mean, that makes perfect sense. And I think that's important. That can be easily overlooked when we focus only on the data or the facts of the matter, and putting them into the context is so important. I wonder if you could envision sort of a reader before reading your book, somebody who's coming with relatively little, I mean, it depends obviously, but before and after reading your book, what do you hope might have changed? What thoughts or practices or skills would somebody leave with? And not to put too much pressure on you and your book, but in general, I think it helps us understand, like, what does a novice data analyst look like, and how can you tell them apart from somebody who has gained not necessarily expert knowledge, but a step above? What are some of those differences? What do you hope that people will get from this book and from just becoming better data analysts in general?
One of the blurbs that we have, it says that our book will teach 95% of what the modern day data analysis need. And the person who wrote this got a Nobel Prize in economics last year. So that means something.
Yeah, that's good
to brag, but not to brag, but still. And I think this idea that we don't teach everything, but we teach the key points, and then so somebody who has gone through the book would kind of have, some experience in basically 4 areas. So the first one would be how you start working with your data, how you explore them, how you wrangle it, understanding, tidy data concepts, understanding how you collect data and what it means, and the foundation, the boring stuff in a sense, but the important stuff, how you visualize data. So I think that's one set of skills and experiences. The second is how you find patterns in the data, run regressions, think about how do I interpret my coefficients. So certainly being able to interpret model coefficients, that's something we really hope people will do after the book, because something that we hammer this very hard and maybe repetitively, that this is what it exactly means, and what does that mean for the business or the policy. The third would be having this prediction mindset, that you are able to think, okay, so I have my data, I want to train a model, I want to build a model that can predict outside of the data that I have. How do I do this? And I think the methods are important, but they're going to change, right? So this is the part that algorithms change, there are new ones. So you need to understand kind of why do you need algorithms to solve certain problems, and what is their essential idea of machine learning, but have this prediction mindset. I think that's important. And the fourth one would be to be able to analyze the causal effect of interventions that's happening both in business and in public policy, that you make changes and you want to understand what are the causal effects of that. So to be able to do that, to have the key tools that you can use, and this the causal thinking, what might have caused this, how do I prove this? I think these are 4 groups of things that we hope the readers will have by the time they have done with the book. And not only, we didn't really talk about much, but there is kind of an ecosystem around the book, the code and the data. So we also want people not only to read through the book, but have the full experience of going through the code in their favorite language. Mm-hmm. And this is how you really understand that. You go through the code, that you go through the exercises, you try to do it on your own. And this is not like it's not like for 1 week, instead of watching Netflix, right? This is a longer journey, as it were.
That's actually a perfect segue, because one of the last questions I tend to ask guests that I picked up from Rebecca Caligeris, who does the other podcast, is a little bit shorter in perspective. It's what 1 or 2 things could people do within the next day to improve? So we've already established, I don't think anyone can read this book in 1 day. It's going to take more time. It's going to take more practice, especially to become familiar with these concepts. And that's obviously something people should do. What's something that people who either are or want to be data analysts or want to work with data analysts more effectively, what can they do, today or tomorrow that would already start to improve things?
I know. I mean, it's fantastic to see the American way, that you wanna have, like, what can I do now, and that's, and I love it. I appreciate it. So I think most people would have some background in data analysis or econometrics or statistics or data science by the time they pick up the book. Not all of them, but some will have. So one purpose that we had is to have very very short sections, 2-3 pages. A very structured book, so that people can fill in their gaps. So I think one thing that you can do is say, what do I remember from college, or what do I remember? What are the areas that I have vague memory, but I don't really remember? Try to go and find it. It's well structured, so you're going to find it. And then read around that topic. Maybe read the case studies first and then go back to the theory. So try to plug holes in your knowledge. Again, most people will know a little bit about visualization, or a little bit about statistics, or a little bit about regressions, or a little bit about predictions. So one thing you can start with is identify what are the bits and pieces where you know a little bit, but you don't remember that much. Find those bits in the book and plug the holes. And then you're going to come away with, well, now I understand. So I have this vague memory, but now I remember. And this is really intentional. We really want this to be kind of also a handbook, right? For professionals who have studied stuff, and they use it to look up that they don't remember. And
Yeah.
and that was one of the, this is a college textbook, but also a handbook for practitioners to look up stuff that they want to, just plug the holes.
Great. Yeah, I think it definitely serves that purpose. And yeah, it gives people a lot to think about. It's been great talking to you, Gabor. And I wonder if people want to learn more about you or follow your work, where do you recommend they check out?
Well, the textbook has a website. It's gaborsdataanalysis.com. So, both the co-authors are Gabor, so it's gaborsdataanalysis.com. You can find it. And there is a lot of details about the book. You can look into it. You can look at the chapters, the case studies. So that's one thing. The other is I am on Twitter, both personally at Gábor Békés, or the textbook also has a Twitter handle at Gábor's Data. So you can find us on Twitter. That's where I'm most active. And so if you're interested to learn more, follow me or have a discussion on Twitter. And look up the textbook, look up the GitHub repo. So the textbook has a large GitHub repo with all the codes, the data, and more. We now have online courses in R, Python, and Stata that comes with the books. If you want to learn coding or a new
Excellent.
language, you can also use that. So there's a lot of goodies both on GitHub, on the website, and we can have a chat on Twitter.
Perfect. Well, yeah, there's so much to learn from it, and it's obviously a continuing conversation as things grow and the field grows. But yeah, this is an important contribution. It was great talking to you and being able to pick your brain for an hour. I really appreciate it, Gabor.
Yeah, it was fantastic. Thanks a lot.